Hello my dear students, how are you? Namaste to all. Today I am going to describe very interesting Markonikov's rule that is very useful for knowledge as well as what to see examination viewer point. So what to see Markonikov's rule and peroxide effect. Yes, very important. Markonikov's. So at first we have to know Markonikov's rule. So what is the Russian chemist? Russian chemist. Yes. So he gave very famous rule for preparing what you see any halo compounds. Yes. So when you talk about the Markonikov's rule, he is what you see Russian chemist. So he gave his statement, a rule we can say, the addition of rule is like this. The addition of hydrogen from HX hydrogen halide, X maybe chlorine, maybe bromine, maybe iodine, HX water, alcohol, etc. The addition of hydrogen from an acid, maybe HX, X maybe chlorine, maybe bromine, maybe iodine, and water, or we can say alcohol, takes in unsymmetrical, that is very important point, unsymmetrical, unsaturated hydrocarbon takes place where the number of hydrogen may be single atom, maybe more than one atoms, takes place where the number of hydrogen atoms are, it's already text over here. So takes place where hydrogen atoms are higher. So what we see now when you talk about the Markonikov's rule, so in this case what you get, the addition of hydrogen from an maybe hydrogen halide, X maybe chlorine, bromine, iodine, maybe water, maybe alcohol, etc. in unsymmetrical unsaturated hydrocarbon takes place where the number of hydrogen may be single atom, maybe more than one atoms are higher. So we take very simple example like this. At first we have to know unsymmetrical hydrogen. So unsymmetrical CH3 CH2. So that molecule is known as unsymmetrical. Why it is known as unsymmetrical? Because in this case double bond, in this case what is single bond. So there are no plane, plane, or we can say imaginary line. Plane means it is an imaginary line which divide the object into two. Half is known as plane of symmetry. So in this case, plane of symmetry does not pass. Why? In this case, double bond, in this case, single bond. So that molecule is known as unsymmetrical. If in this case double bond, then what is the plane of symmetry is present over there. So in this case, no plane of symmetry. Why? Because in this case single bond, in this case double bond, unsymmetrical. And another criteria is unsaturated hydrocarbons. Unsaturated means, hydrocarbon must contain carbon-carbon double bond and triple bond. That is known as unsaturated. So we are clear what is unsymmetrical, what is unsaturated. Yes. So when this is supposed that is treated with HCl, yes, hydrogen chloride. So we take very simple example. So what we see, according to Markonikov's rule, the addition of hydrogen takes place where the hydrogen are more over here. In this case, 2 hydrogen atom, but in this case only 1 hydrogen. So in this case 3 hydrogen, no doubt. But in this case there is no addition. Why? Because in this case no double bond. There is no pi bond. So I will talk to you later about the pi bond, sigma bond. So where there is double bond, where there is triple bond, so what we get? Pi bond. And pi bond is what we see delocalized in nature, unstable in nature. So what happens? So this nucleophile attack, this is nucleophilic, nucleophilic addition. Why? This nucleophile attack over this carbon. So what happened? So 1, 2, 3, 4, 5 is possible? Not possible. So that pi bond shift over this carbon. Again, so this nucleophile means having negative charge and maybe what's a lone pair of electron. So in this case negative charge, so that attack over this carbon. So what happened? 1, it makes bond with chlorine. 1, 2, 3, 4, 5 is possible? Not possible. Carbon is always tetravalent, always keep in mind. So where there is double bond, where there is pi bond, that is delocalized in nature, or we can say unstable in nature. So that pi bond shift over this carbon. So what we have? CH3, negative charge, H, what do you say? C. So what do you see? Chlorine atom adds over here, hydrogen, in this case what you see? CH2, negative charge. So that pi bond when comes over this carbon, so what develops over here? Negative charge develops. If here negative charge, so what happens on the H plus? That H plus electrophile, that is electrophile. So that adds to this, what you see? That is the nucleophile. So when it adds over here, so what we have? CH3, CH, chlorine, and that is CH3. So what the name of this compound? 1, 2, 3. 2 chloro. How many carbon? 1, 2, 3. So what we have? 2 chloropropane. So you are clear? So according to Markonikov's rule, the addition of hydrogen from an acid in unsymmetrical, unsaturated hydrogen takes place where the number of hydrogen are higher. So in this case 2 hydrogen atom, in this case only 1 hydrogen. So that hydrogen adds over this, not adds over this. Yes, you are clear? That is the first example. Yes. Second example is, what is CH3, same, CH3, CH, double bond, that is known as propane. Yes. So when that is treated with H plus OH minus, so that is water. So always formation of electrophile and nucleophile. H plus is electrophile, OH is nucleophile. So again, this nucleophile attack over this carbon and that pi bond shift over this carbon. So what we have? CH3, COH bond, H, and what we see? CH2 negative charge over here. Why? So that pi bond shift over this carbon, so it develop negative charge. Now this H plus, that is electrophile, adds over here, and what we have? CH3, H, OH, and what we get? CH3. So what the name of this compound? 1, 2, 3. So what do you see? How many carbon? 3 carbon. Propane to ol. Yeah, better to say propanol. Generally, we start to naming our location of the what you see carbon from 4 carbon atoms. Never what you see 3 carbons. Yes. So that is about second example. Third one is CH3, CH3, CH2. 1, 2, 3. So what the name of this compound? 2-methyl. Prefix over here. 2-methyl. How many carbon? 1, 2, 3. So what we have? Propane. Propane. Yes. How many carbon? 3 carbons. What we have? Propane. En means double bond. So when that is treated with, suppose, HBr. Yes, again same reaction. That Br, what you see, attack over this carbon. That pi bond shift over this carbon. So what we have? CH3, CH3, what we have? Br, and what we have? CH2 negative charge. That H plus electrophile adds, and what we have? CH3, CH3, Br, what is CH3? Yes. So naming of this compound is 1, that is first carbon, second carbon, third carbon. So what we have? 2-bromo alphabetically, 2-bromo, 2-methyl, 2-methyl propane. So I think you have clear what are the Markonikov's rules. Very, very important to make any halo compound. What you see? Alcohol. We can prepare what see alkoxide compounds. So many compounds you can prepare from Markonikov's rules. That is very, very important for the synthesis of any halo compound, any alcohol, any what you see alkoxide compound you can say. Yes. So I think you have clear what is the Markonikov's rule. Next one is what we say anti Markonikov rule, or we can say simply that is also known as peroxide effect. Yes. So what it means? Anti means orientation of the what you see H plus is just reverse of Markonikov's rule. In this case, in short, when you tell what you see, anti means what you see, just reverse of here orientation means orientation of H plus is just reverse of that reverse of Markonikov's rule. Markonikov's rule. So what the statement over here? It is the anti of Markonikov's rule. The addition of hydrogen from from an acid, we can say HX, water, alcohol, etc. in presence of dialkyl peroxide, means ROO, that is dialkyl peroxide. We can say benzoxide, benzoxides, benzoxide, C6H5 COO, COC6, that is known as benzoxide. So addition of phosphate hydrogen from an acid in presence of dialkyl peroxide. So main role of this dialkyl peroxide compound in unsymmetrical, unsaturated hydrocarbon takes place where the number of hydrogen atoms, maybe single atoms, maybe more than one atom, where the number of hydrogen atoms are lower. In Markonikov's rule, higher, but in this case, lower. So always be alert, be sincere. Yes. So we take very simple example. Like example is like this: CH3, CH. So that is propane. That is unsymmetrical carbon. Why? Because in this case double bond, in this case single bonds. And in this case no passing of forward plane of symmetry, you can say. So propane. So when this is treated with HBr, so always there is formation of electrophile and nucleophile. That is very, very, very reactive in organic compound, we can say. So in this case, what we observe over here? So in this case, the addition of this H plus takes place over here, not this carbon. And always the main role of over here is what's ROR, peroxide compound. Peroxide, only in presence of peroxide. So what the orientation? In this case, bromine nucleophile attack over this one, this carbon, and that pi bond shift what we see, this carbon. Yes, what you see over here? CH3, C negative charge, H, CH2, what we have? Pr. So negative charge develop over here. So that H plus now, adds over here. So what we have? CH3, H, CH2, Br. So what do you see? What do you observe over here? So orientation of this H plus is just reverse of Markonikov's rule. In Markonikov's rule, what do we observe? The addition of hydrogen takes place where the number of hydrogen atoms are higher. But in this case, what do you see? Takes place where the number of hydrogen is lower. So what do we have? What the name of this compound? The name of this compound is 1, 2, 3. So we can say 1 bromo. How many carbon? 1, 2, 3. So what we have? compound is different, orientation is different, addition of H is different. So all are different to Markonikov's rule. Yes. So that is about the what we say Markonikov's rule. That is nucleophilic addition reaction. But in this case, note only HBr follows peroxide in short, peroxide effect, peroxide not HCl and HI. Sometimes ask a question, explain why. Explain why. Now question arises, only HBr follows what we say anti-Markonikov's rule, not follows HCl and HI. That is very interesting question and generally ask you in examination. So what we have? So look at the mechanism. ROR, that is dialkyl peroxide. That is dialkyl peroxide. So in presence of sunlight, HB means sunlight. So what you get? 2 molecule of alkoxide free radical. That is 1 electron means free radical. That is alkoxide free radical. Free radical means single atom or group of atom containing single electron, odd electron you can say. So that is known as free radical. Yes, and it liberates delta H. Delta H means enthalpy. It liberates about 87 kilocalorie mole. 1 mole liberates how much? 87. That is very important point over here. So during the formation of alkoxide free radical, it liberates how much energy? Minus means liberates. How much? 87 kilocalories. So now look at what mechanism takes place over here. So I have already told you the HBr only follows. So what do you see? HBr for the breaking of, for dissociation. Dissociation means breaking down. Dissociation. Dissociation means breaking down. To break the what see HBr into H plus ion and Br, we need 87 kilocalorie per mole. So that energy is supplied by this alkoxide ions. So we have no problem. So in this case, what do you see? Easily HBr easily dissociate. Dissociate means breaking down into H plus and bromide ions and reaction takes place easily. Yes, in this case no problem over here. But when you talk about the what you see HCl, so to break this bond, how much energy we need? 103 kilocalorie per mole. To break this HCl, what we need? 103 kilocalorie. But in this case, how much we get? Only 87 kilocalorie. So that lower energy can break the what you see bond of this HCl. So cannot break what you see. Cannot broke. Yes, better to say cannot break. Yeah, cannot dissociate. Better. Dissociate H plus and chloride ions. So this reaction is not favorable. Yes, so clear why HBr only what you see participate in the reaction, not HCl and not HI. Again, when you talk about the HI, it needs only 71 kilocalorie per mole. So we get 87 kilocalorie, no doubt. It dissociates into H plus ion and iodide ion. But in the same condition, what it reverse? Again, what we get? HI. This HI break down easily, no doubt, because it needs only 71 kilocalorie. But what happens over here? At that condition, H plus and iodide combine to each other, and what you get? Unionized. That is ionized. That is, if H plus and iodide ion are not available, so this reaction takes place over here. It means there is no reaction. Why? Because there is no reaction because not of H plus and iodide ions. So I think you have clear. So for breaking or dissociation of HBr, how much energy we need? 87. So that energy liberated by the formation of what we see dialkyl peroxide. That is very normally and takes place easily. In this case, no any problem over here. But we talk about the HCl. What do we see? It needs 103 kilocalorie per mole. It means it does not dissociate into H plus and chloride ion. It means cannot dissociate it plus ion. So this reaction is not favorable, not possible. You can say not possible. Yes. But when you talk about the HI, what do you see? It needs only 71. It needs only 71. That energy is sufficient. So in this condition, it breaks into dissociate into H plus and iodide ion. But in the same condition, it combine to each other, and what you get? Unionized HI. It means there is no available what you see H plus and iodide ion. It means there is no reaction. I think you have clear why HBr only follows Markonikov's rule, not HCl, not HI. So I think you have clear. Yes. So examination generally asks you question. So what is Markonikov rule and peroxide effect? Give suitable example. Next question, explain why explain why HCl and HI not why HCl and HI not supported by anti Cope's rule, or we can say better peroxide. That is also known as, I have already answered you all the answer of this question. Next model is ask you find A and B with IPSC name in the following reactions. So look it over here. So examination ask you, it's very important. So what do you say? CH3 CH double bond CH2, that is propane. So when that is treated with HBr, that is Markonikov's apostrophe rule A. ROR, that is peroxide effect B. What the A, what the B? Generally asking examination, very very important this question. Yes. So what the answer of this question? I think you can do it. So what you see in this case, A compound is what we have? CH3 C, what do you say, BR H CH3. What the name of this compound? Two position, 1 2 3, 2 bromo propane. Yes. Big. When you talk about the B, so what do you see? That is anti-Markonikov's rules. So what do we have? CH3 CH2 Br. What the name of this compound? 1 2 3. So what do we have? 1 bromo. How many carbon? Remaining carbon is 3. So what do we have? Propane. If you write what you see, A is this one, B is this one, with IPAC name will get the full marks. It's very simple and generally asked you in examination. Always be sincere. So I thank you for watching this important video. Now next day I will come with inductive effect. That is also very very important for examination view, and as well as we can say knowledge. Inductive effect. So remember it.